The Pythagorean Theorem, this is a digital lesson, and it introduces students to this idea that if we have a right triangle, the Pythagorean Theorem states that if the lengths of the legs of the right triangle are a and b, and the hypotenuse is c, then a squared plus b squared equals c squared. So we're going to start the students with some vocabulary. A right triangle is a triangle with one 90-degree angle. The hypotenuse is the longest side of a right triangle. It's always opposite that right angle. And the legs are the other two sides, and they form the right angle. So students are just going to be taking that vocabulary, and they're going to be typing in either hypotenuse or leg to label each of these sides. So this one would be the hypotenuse, and they're just going to type that in for all of these. Now we can find the missing side of a right angle by using the Pythagorean theorem. We're going to set up an equation. If a squared plus b squared equals c squared, then a and b would be these two sides, the legs. We're going to square them. A squared plus b squared equals c squared. So here we get 36 plus 64 equals c squared. I'm going to combine like terms. I get c squared equals 100. To isolate the variable c, we're going to do the opposite of squaring a number. We're going to take the square root. So if I take the square root of both sides of the equation, I get c equals 10. And I know the hypotenuse on this triangle is 10 centimeters. So students have several examples. You can go through some of these together and then let them solve some on their own. Here we have the legs, which are 3 and 4, so I have 3 squared plus 4 squared equals c squared. That gives me 9, and they're just going to type these in. Combine like terms. Take the square root of both sides, and they get their missing side of 5 inches. They're going to do the same thing on the next couple of slides. When they get to slide 9 and 10, they're going to find that they can't actually take the square root of this number, so this will be their answer. It will just be a square root. Slide 11, now they're going to be solving for one of the other sides. So here we know the hypotenuse, we know one of the legs, we're going to solve for the other leg. So we have a squared plus 4 squared equals the hypotenuse, which is 5. So a squared plus 16 equals 25. They're going to subtract 16 from both sides, and they're going to get 9. Take the square root of both sides, and they're going to get the length of that leg is 3. So 3 feet. And they'll do the same thing again, get a little bit more practice. When they get down to slide 13, they're just going to use scratch paper, and they're going to set up their own equations and solve them for the missing side. Now when we get to slide 16, we're going to explain the converse of the Pythagorean theorem. So if we have a triangle, and if a squared plus b squared equals c squared, we know that that triangle is a right triangle. So it's kind of the Pythagorean theorem in reverse. And they're going to do that on the next slide. So they're given 4 triangles. They want to use their scratch paper and solve 6 squared plus 8 squared equals 10 squared, and see if it's equal. See if that Pythagorean theorem works. If it does work, it's a right triangle. And if they find it's a right triangle, they're just going to type an X in the square next to the right triangle. The next slide has an example of when we have the diagonal of a rectangle. Now we know if it's a rectangle that this angle has to be 90 degrees, which makes it a right triangle. So we can figure out the length of the diagonal using the Pythagorean theorem. And they're going to do that on this one. Now if we have a right triangle on a coordinate plane, here we can count the units on each side. So we know this side's 3 units, this side's 4 units, and we can figure out this third side by using the Pythagorean theorem because we know this has to be a right angle. They're going to type in the measurement of each unit, of each side here. Now we get a real-life example. We have a 17-foot ladder that's placed against a wall, 8 feet from the wall, And so this would make a right triangle. We know the hypotenuse is 17. We know this leg is 8. We're going to figure out the length of the other leg. Now when we get to slide 22, we want to prove visually that a squared plus b squared equals c squared. So if we have a right triangle and they have sides of 3, 4, and 5, we're going to place a square here that's 3 units on each side. We have a square here that's 4 units on each side, and for the hypotenuse, a square that's 5 units. We want to prove that each of these, the area of each of these is going to equal the area here of this square next to the hypotenuse. We're going to do that on the next slide by moving these squares into place. So we have the area of these two squares should be equivalent to this. That means every one of these red and blue squares should fit into the larger square. And they're going to do this by just clicking and holding on each one of these squares. They're going to use this little blue circle to turn it into place. And they're going to see if every single one of these squares will fit into the larger square, red and blue. So that just proves the Pythagorean theorem visually. So this is a digital lesson on the Pythagorean theorem.